Hello everyone, my name is Izzy and welcome to Clear IT. Today we're going to talk about the hard drive, the long-term storage. This is where all your data, all your files are stored. So if you were to take the one part of your computer that has everything on it, the computer, it would be the hard drive. If you take your hard drive, stick it in your pocket and take a walk, you are walking with your computer in your pocket. Now, first of all, I gotta clear up a misconception. For some reason, many people, not professionals, refer to the hard drive as memory. They're running out of space on their hard drive, running out of disk space, and they say, oh, I need more memory. I don't know why. I don't know who's responsible for that, but I just want to make it clear. Memory is RAM, has nothing to do with the hard drive, and getting more memory is not going to help you if you're tight on storage space. So let's just get that out there. I hope that helps some people. Back to us. The hard drive is the long-term storage. This is where your data is stored. When you turn on your computer and your operating system starts, those files are stored on your hard drive. When you open programs, maybe it's your browser, Firefox, Chrome, Internet Explorer, Edge, Microsoft Word, Excel, Outlook, QuickBooks, whatever it may be that you're using, playing games. All those programs are stored on your hard drive. All your files, your pictures, your videos, everything is on the hard drive. As a matter of fact, if your computer dies, most of the time you could take your hard drive, connect it to another computer, and you could read all your data. Okay, so it's kind of important. So, of course, like all other computer parts, there are many variations. There are a lot of details, different specs, different things to know. So let's jump in, let's have a look at it, and let's try to understand this on a better level. The first thing we need to discuss is the hard drive, the HDD, or the hard disk drive. Okay, this is a standard hard drive. They come in two sizes, 3.5 inch and 2.5 inch. The 3.5 inch is typically found in desktops. The 2.5 inch is typically found in laptops, although you can put a 2.5 inch hard drive in a desktop with an adapter. That's fine. Many all-in-one computers actually use laptop hard drives, because they're compact. They gotta pack in a lot of stuff, and the smaller hard drives fit nicer. Then there's the SSD, or the solid state drive, while the hard drive is actually a spinning drive, kind of like a CD or a DVD. Inside the hard drive, if you were to open up, there are multiple platters and they're spinning. And the data is stored on these magnetic platters. SSDs don't work that way. They're known as they're called solid state storage, and they come also in a couple of different form factors, and they are much, much faster. We're going to talk about the differences in greater detail shortly. But there's no 3.5 inch SSD. They don't make it. They make 2.5 inch, and then they make what's called M.2 or M.2. These are these much smaller sticks that actually fit directly on the motherboard. Now, if you were to open up an SSD, the 2.5 inch one, it also has something like that M.2 inside. But they kept the form factor of the laptop hard drive, and that's why they make these 2.5 inch drives. So what are the important specs that we're looking for in hard drives? Now, when I say hard drive, I mean hard drive and SSD. They're kind of known in general as the hard drive, even though technically the hard drive are those spinning drives. When it comes to hard drives, we measure RPM, revolutions per minute. Now, hard drives are the slowest component on the computer. Okay, so we talked about CPU, we talked about RAM. These are fast. The hard drive is way, way slower. We're talking about CPU and RAM doing billions of operations a second, and the hard drive is maybe doing thousands, so much, much slower. A standard desktop hard drive turns 7,200 RPM. Standard desktop 3.5 inch drive. A standard laptop 2.5 inch drive spins at 5,400 RPM. Now, they make desktop drives that also go 5,400 RPM. They make laptop drives that can spin at 7,200 RPM, but those are not so common. They also have a couple of other speeds. I think there's a 5,900 out there. That's for the consumer products, for the desktops and laptops that people buy. There's also enterprise drives that spin faster, 10K and 15K, 15,000 revolutions per minute. Those are not for consumer computers, but they are out there. And again, the form factor is the same, 2.5-inch or 3.5-inch. Okay, so that's one factor that we need to consider. Obviously, the more RPM, the better your performance will be. Another thing is throughput. Okay, throughput is how much data can be processed, either read or written in a given time. So we measure throughput usually in megabytes per second. Okay, the more megabytes per second that the drive is capable of reading or writing, the better the performance is. And on a similar note, there's another metric that we look at called IOPS, or input output per second, which is how many operations can be done per second. And they're not the same thing. Okay, so you could have one operation that is using more throughput, or you can have many small operations without actually reading or writing a lot of data. So there could be many operations with very small amounts of data, or there could be few operations with large amounts of data. So these metrics are not the same. These are two things that we look at. In general, IOPS is something that we measure with SSDs. Okay, how many operations can be performed per second? The IOPS on SSDs are way higher than on hard drives. Throughput we will use for both, but often it'll be a measurement seen in hard drives. It doesn't have to be though. Either way, again, we're measuring one thing, and that is how fast are they. Okay, so one metric that we look at, whether it's going to be by checking the RPM, checking the throughput, the IOPS, we are checking how fast are they, how fast can they read, how fast can they write. And the other thing is the storage capacity. How much data can I store on this hard drive? We measure this in gigabytes and terabytes today. So there's 1024 gigabytes in a terabyte. A small hard drive or a small SSD might be as small as maybe 120 gigabytes. And a large drive could be multiple terabytes. I know they even make a 12 terabyte hard drive and maybe even bigger. Okay, so these are the two factors. Now, for some people, space is very important. I need a lot of space. I have a lot of stuff. I have a lot of files. I have a lot of videos. I need a lot of storage space, storage capacity. So what's important to them is the terabytes. Other people don't have a lot of data, but they want it to be fast. So IOPS or speeds are important to them. Of course, optimally we would want both, but there's some challenges, and those challenges is that SSDs are more expensive, or flash storage is more expensive than hard drives, which means that usually SSDs will have much smaller storage capacity. So where a standard hard drive might come at 1 terabyte, your standard SSD might only be 250 gig, which is a quarter of that. Okay, that's because it's more expensive. So you need to figure out what you need. Of course, you could have more than one. You're always going to have a primary hard drive or a primary SSD. That's going to be the drive that your computer boots up to when you turn it on. But you could have a secondary drive, and maybe you'll have an SSD for your primary, and a large hard drive as a secondary drive to store, your extra data, your extra files. I want to mention again form factor. I mentioned that there's 3.5-inch drives and 2.5-inch drives. 3.5-inch drives are only for hard drives. 2.5, they could be an SSD, or they could be a laptop size hard drive. Another form factor is called M.2. M.2 are these smaller sticks, kind of similar to RAM in a sense, but even smaller than desktop RAM. And they slide right into your motherboard. So they take up very little space. And they connect right to the motherboard. M.2 is just a form factor. It's not a technology. M.2 isn't necessarily faster than a 2.5-inch drive. M.2 is only for SSDs. There's no hard drive, obviously, that's doing that. Okay, so when we're using SSDs, we have a 2.5-inch option, and we have an M.2 option. That's the size. And finally, there's PCIe. So PCIe is a technology for transferring data on the motherboard. Motherboards have slots where you can stick, especially desktop motherboards, where you can stick different peripherals into them. So for example, maybe a graphics card, or maybe a NIC, or maybe some other kind of card. PCI Express is capable of transferring data very, very quickly. So there are also SSDs that can actually connect directly by fitting into a PCIe slot, although it's a lot less common. The next technology I want to talk about is the storage connection interface. And this is the way data is transferred to and from the drive. So you have a hard drive and you want to transfer data out to the motherboard to be processed by the RAM, the CPU, something should display on the screen, and so on. There's several technologies that are used here. The first is, and the most well-known and widely used, is called Sata. Now Sata is capable of transferring data at 3 gigabits per second, which is pretty fast, but it's the slowest of the bunch. Now all 2.5-inch hard drives, 3.5-inch hard drives, even 2.5-inch SSDs, they're all using the Sata technology for the most part. We'll talk about some of the others shortly. And that means that there's a maximum throughput of 3 gigabits per second. Now that could be in the form of a Sata cable. So our 2.5-inch, 3.5-inch drives are going through the Sata cable down to the motherboard. So this cable connects to the hard drive, connects to the motherboard. That's how the data is getting transferred. It could also be in the form of M.2. So we have these M.2 SSDs that can connect to the motherboard, but if they're Sata SSDs, they're still going to have the same maximum or the same limitations on those data transfer speeds. Then there's SAS. SAS is an enterprise technology. You need enterprise drives, enterprise hard drives, which are a lot more expensive. They also come with all kinds of different features, which I'm not going to get into because, again, they're not for consumers. They're not what you're going to put in your desktop. They're what we use in servers. They're capable of different, for example, they have longer life. You could have more reads and writes. They can maybe handle shock better in some cases. They are capable of having data from multiple sources being written at the same time, and so on. So they're better quality drives used for servers mainly, enterprise drives, and they use the SAS technology. SAS is capable of 12 gigabits per second, so it's faster, theoretically faster. But again, servers, enterprise, not consumer drives. And finally, there's NVMe. NVMe is the fastest of the bunch. NVMe connects directly to the PCIe lanes on the motherboard. So NVMe, we talked about having an SSD that can connect directly to a PCIe slot. Well, these don't do that. This could be in a couple of form factors, which we're going to talk about. They come in 3 different form factors. So again, we have NVMe is the fastest of the bunch. It's also the newest of the bunch, and is capable of tremendous throughput. Now, the most common NVMe drives are using the M.2 slot. So we talked about M.2 before, having an M.2 SSD, but we have 2 kinds of M.2 SSDs now. We have a SATA M.2, and there's an NVMe M.2. The NVMe M.2 will have much better performance, will have much greater read and write speeds than the SATA or even SAS. Okay, they can also be in the form of PCIe, which would be a card, a storage card that actually goes right into the PCIe slot on the motherboard. It's not as common for desktops. And then there's U.2, which is kind of rare, but it's a new technology. It's out there. They're actually coming out soon with U.3, and that is a 2.5-inch form factor. So it looks like that 2.5-inch drive that we have in laptops, SSDs, except that it uses the NVMe technology, and it is capable of much, much faster speeds. Thanks for watching, guys. Please take a moment to like, subscribe, and share this video. And of course, don't forget to comment. Ask questions, share your experiences, and I'll see you in the next video.